right, as we've been working through creating Taylor polynomials, I'm sure you've asked yourself the question, not the question, why are we doing this? The question, how would you know whether you should use a degree 5 or degree 3 or degree 7 to estimate that function? Well, what mathematicians use are finding the errors in calculating the difference between the polynomial and the function, and then that's how they'll decide which degree is most appropriate. So what we're going to do at the end of this lesson is be able to find the error in estimating a function using a Taylor polynomial, and we will actually be using something that's called the LaGrange error. All right, so we're going to have f of x be our actual function, so it could be cosine of x, it could be 1 over the square root of x plus 4, anything we've been dealing with before. And then p of x is going to be our Taylor polynomial that is approximating the function. Our error is going to be calculated by finding the absolute value of the difference between the two. So we're just pretty much going to take the actual one minus the polynomial and see how close we get. Our formula is not going to look quite that simple as we get into it though. Okay, the LaGrange error formula is found by our error is going to be less than or equal to. This says the max of f n plus 1, and that actually does not mean raised to the power, that actually means the derivative. So whether it's a fourth derivative or third or second or whatever of z times x minus a over n to the n plus 1 all over n plus 1 factorial. All right, in order to use this formula, it actually is not a hard formula to use at all, as long as you know what everything means in the problem. Okay, the first thing that we need to know is that n is the degree. So whether we're trying to find how close a 5th degree polynomial fits or a 7th degree polynomial fits, that's what we'll be using. My x is going to be the x value in question. So I might want to know if I'm looking at x equals 5.6, if I plugged 5.6 in the function and I plugged 5.6 into the polynomial, how close of an answer would I get to each other? Okay, the next part would be my a, which is my center. So is it centered at 0 or 1 or 2 or wherever? And then the final thing is my z. Z is always going to be a number somewhere in between x and a. And what we're going to be looking for, it usually will be x or it will be a. This is just going to be the number that gives us the largest derivative. And that's why this word max is up here, because we want the biggest derivative possible to go right here. All right, so again, we'll either usually choose x or a. One of those two values for z will give us the largest derivative. All right, so we are going to go ahead and go right into an example. This says to use that LaGrange error formula to estimate the error if the square root of 1.2 is approximated with a Taylor polynomial of degree 3 centered at 1 for the square root of x. So we're using our function as the square root of x. Notice we really don't care what the polynomial is. We just want to know, does degree 3 do it for us? Does it give us an answer that is close? So things we're going to look at, our x in question is going to be 1.2. Our n, our degree, is 3, so that's what we're checking. Our a is 1 because that's where we're centered. And then my z value is going to be somewhere in between 1 and 1.2 because it's always going to be somewhere between the a and the x values. All right, and we'll deal with which one we want that to be in just a minute. All right, so we're going to go ahead and get the formula set up, and just looking at what we did when we wrote down that formula, we're going to have the max of f, and then remember that it said the n plus 1 derivative, and since n is 3, we'll be looking at the 4th derivative, and that will be at that will be at z, and we haven't determined that yet. And then it's going to be over n plus 1 factorial, so it'll be over 4 factorial, and then it will be times x minus a, so it will be 1.2 minus 1 raised to the 4th power. Okay, so now what we are going to do is, if I would like to find the biggest derivative I can, I first of all have to find the 4th derivative. So I'm going to come over here and do a little side trip. So we'll have f is equal to the square root of x, which is actually x to the 1/2. Okay, so f prime will be 1/2 x to the negative 1/2. And f double prime will be negative 1/4 x to the negative 3/2. And then f triple prime will be 3/8 x to the negative 5/2, and then the 4th derivative will be, and that's when we start putting numbers instead of the tick marks. When I do that, I'll get negative 15/16 x to the negative 7/2. And this one I'm actually going to get rid of the negative power because this is something we're going to actually have to plug a number into. So the 4th derivative will actually be negative 15 over 16 x to the 7 halves. All right, so now I just need to decide, should I plug in 1 or 1.2 into this answer? What should I put right here? That's what I'm trying to decide. Okay, so if I look at this, would it be better, am I going to get a bigger answer if I plug in 1 or plug in 1.2? First of all, I'm going to tell you that we will be ignoring the negative sign because we're going to take the absolute value anyway. So with disregarding the negative sign, which one will give me a larger answer? And I notice that if I plug 1 in, that will give me a bigger answer than if I were to plug in 1.2. So we are going to be evaluating, this is actually going to be the derivative at, the fourth derivative at 1. So if I put in the fourth derivative at 1, I know that 1 to the 7 halves is still just 1, and so this will be negative 15/16, and I can really just put 15/16 if I really want, because we're just taking the absolute value anyway. Okay, and it's going to be the absolute value of that whole thing. And fortunately on this section, because our errors will come out to be small decimals, from this point on we can go ahead and use our calculator. So we'll just type that all in our calculator. If you do not remember where absolute values are, you will go to Math, and then you'll choose num, and then from there should be a button that says ABS, and that should create absolute value bars for you. So once you do that and type it all in, we'll get an error that is less than or equal to 0.0000625. So notice that is a pretty small error, which means a third degree polynomial gets you pretty close to the actual function. And I think that is about it. So hopefully now you can use the LaGrange error formula to find the error in estimating functions.